Hi guys, welcome to today's class, still on friction and indeed physics. Today we have a problem here on friction. It says a body pulls in a 10 Newton force weighing 96 Newton as shown in the figure below. This is the figure representing the statement here. Pulls in a 10 Newton, drags, the body is dragged with a 10 Newton force. Yeah, and the weight of the body is 96 Newton. As shown in the figure below. The question here, A, is at what rate will the wagon accelerate? B, with how large a force is the ground pushing up on the wagon? Solution. Now I have that given, I usually say, let's see the parameters that we have here. We have weight, W, to be 96 Newton. We have acceleration due to gravity, G. If acceleration due to gravity is not given, we assume it to be 9.8 meter per second square, except it is given. But once it's not given, it's presented at 9.8 meters square. Then we have force here, the force which pulls, the body is pulled with, or which pulls the body rather, to be 10 Newton. And the mass of the body is not given. Now, let's resolve the forces that are present in this body. We have here, this is weight acting downward, and this is the normal force acting upward. Now, this pull here forms an angle of 37 degrees, and the f of y, the force on the y direction, is 10 Newton presented here. And we also have f of s on the s direction. Now, let's resolve these forces here. We have that f of x over 10 from the s direction, s axis, equals to cos 37. Therefore, f of x is equals to 10 cos 37. And f of s here will be, if you multiply 10 by cos 37, you have 7.99 Newton. Now let's also resolve for f of y. Okay. And let's also resolve for f of y. We have that f of y here over 10 equals to sine 37 because of the y-axis. And f of y here will be equals to 10 sine 37. Therefore, f of y, the force on the y-axis will be, multiply 10 by sine 37, you will have 6.02 Newton. Now, the forces here, forces will be represented as this. This is y direction, which is 7. This is 6.02 Newton. Sorry, 6.02. Then from the s direction, this is weight. This is normal force. The f direction will have 7.99 Newton. Now these are the forces that are acting as this wagon is being pulled. Now let's resolve the force. Let's really let's do the calculation of the forces acting. For horizontal force, let's say this is A on the question. Horizontal force, we have the summation f of x is equals to mass times acceleration. And We really don't have mass here, but we are giving weight from what is given in the question. Weight here is equals to mass acceleration due to gravity, and mass here is equals to weight of acceleration due to gravity, which mass is 96 as given over 9.8. Therefore, if you divide 96 over 9.8, the mass here will be 9.8 kilogram. Therefore, summation f of s here will be 7.99 equals to 9.8 multiplied by acceleration due to acceleration. Therefore, acceleration here will be 7.99 over 9.8, which is equals to, which will be equals to 0.8 meter per second square. Acceleration here. And the B, at what rate the A is at what rate with which the wagon accelerates. This is the rate with which it accelerates. Let me just say acceleration equals to 0.8 meter per second square. And the B say with how large a force is the ground pushing on the wagon. Now, for vertical forces, or vertical force rather, the vertical force is the force pushing on the ground. We have summation f of y equals to 0. Therefore, on the ground, we have forces like the normal force plus the force from the y-axis was 6.02 minus the weight. These are all vertical forces equals to 0. So all vertical forces pushing the wagon. Therefore, the normal force here will be equals to the weight minus 6.02. Normal force here equals to, remember, the weight is 96 minus 6.02. Therefore, normal force equals to 96 minus 6.02 will be 89.98 Newton. As simple as that. That is the force with which that is the force with which the ground pushes on the wagon, and this is the acceleration, the rate at which the wagon accelerates. As simple as this. Thanks for watching, and watch out for more problem solutions on forces and friction. Bye.